in NX. My name is Candis, Spraul, and I do the marketing here at Swoosh Technologies. And at Swoosh, we're a full solutions provider, meaning that we do sell the software, we sell CAM, we sell CAD, and all that, and we fully support the software as well as train, and I'll get a little bit into training a little bit later to go over some customization options. But first I want to dive right into, this machine programming. And Matt Beisel is going to go ahead and take over. He's a senior applications engineer here at Swoosh Technologies, and he specializes in CAM, specifically in XCAM. So go ahead, Matt.
Okay, thanks, Candis. So my name is Matt Beisel, and I am an application engineer, as Candis said, and we're going to be talking about CMM and CAM programming. So here's our agenda. So first we're going to talk about what is on-machine probing, why do we want to use it, how does this work in NX, how does this work on the machine tool, then I'll show a live demo. We have quite a bit to go ahead and cover today, so we're also going to cover some CMM stuff. So we're going to give an intro to CMM programming, the benefits of using the CMM in NX CAM, and then a live demo. Okay, so what is on-machine probing? On-machine probing is a measurement technique used on machine tools to use while your part is still in process on the machine. The machine will use a 2D or 3D probe similar to those found on CMMs. And at the end is, a non-marring contact probe that's made out of something such as a ruby. So the probe will contact the part and record the machine position when it contacts a part. When it contacts a part, it records the point and records data. This data can then be turned into meaningful data that can be relayed to the operator quality system or back to the machine for adaptive part processing. So machine tool probes can be obtained from Renishaw or other manufacturers such as Marpos. Okay, so why do we want to go ahead and use on-machine probing? We want to use on-machine probing to avoid the use of additional CMM. So any unnecessary step where the part has to go back to a CMM, because I've seen in multiple facilities is that can be a bottleneck, is using the CMM for everything. You can increase your machine tool accuracy with adaptive feedback on the control, and you have the ability to buy off the part while it's still fixtured in the machine. So it's still on the machine, you can still rework the part. You can find a problem, and some parts that I've worked on in the past, maybe take about 2 hours to set up, and then once you break it down, it's almost impossible to set back up on it again. So you're checking the part while you still can do something about the dimensions there. Okay. This goes to say is it's a valid way of buying off your part while it's on the machine. You can easily obtain SPC data, so you can report points while you're on the machine. You can reduce gauge and tooling cost by not having special gauges made for inspecting certain things on the machine. So you won't have to have a special gauge for the operator to inspect it on the machine. And this is faster than traditional measurement, with those gauges or calipers or whatever, and it'll reduce human error. So what do we need, for this to go ahead and work on NX CAM? Okay, so we need the Renishaw probing hardware installed on the machine. And so this is, the probe head and the relay that's wired into the control, that goes ahead and senses when the probe's triggered. You also need the Renishaw Inspection Plus macros. So this is usually, if you end up getting a Renishaw machine probe, you end up having the macros. So everywhere that I've been that has, a probe, they have the associated macros. So this is like, the G65, P9810, 9811 stuff, macro programs. You need NX9 or higher with a mock package. So it's free. It comes, bundled if you have NX9 or higher with a mock package. And then you also, like the controls that are supported are FANUC and Siemens and Cinemeric controllers. So it's really easy to go ahead and add this capability to your posts. So that's a really good thing. Okay, so how does this work in NX for manufacturing? In NX for manufacturing, you create an operation and select the type as probing. So you can see that here. You select or create a probing tool from the tooling library. You select the features or points you would like to measure. So you can, select a cylinder or probe a surface point. You can create a machine control event if we're doing macro variable assignment or calculations. And so these are all the things that are supported by the macro on the control. And then you create a machine control event to tell the control what to do with it. And then finally, you go ahead and post out some code. Okay, so for example, what I can go ahead and do with this is I can inspect a bore. I can go ahead and inspect a boss. I can update the machine coordinate system depending on how, one of the datum features that you cut, how it comes out. So this can be, really, really useful. And, some people might think, well, who uses this? Well, there's people that, live and die by this stuff. They're probing all the time, and like in a past life when I was using an on-machine probe, as long as I calibrated it, I was able to get, between 3 and 5/10, from the CMM results. So that's pretty good. Okay, so now I'm going to go ahead. Oops, hold on one second here. Okay, so I'm going to go ahead and show a demo here in the software. Okay, so what we have here is NX9, NX9 CAM. And so what I'm going to do is I've got this part that I programmed. So I'm drilling it, opening up a hole, and then I'm cavity milling. So let me go ahead and show you really quick this operation here. So it drills it, and now it's getting rid of this material. So just position in the vise here. Okay, so I've got this hole in this flat cut, okay? So now I want to go ahead and kind of figure out, where everything is, once I've cut the part. Okay, so how do I go ahead and do that? So what you can do is you can go ahead and create an operation in NX CAM, and from the type, I can select, mill multi-axis or hole drilling or, feature recognition, but I can also select probing, okay? Now for probing, what we have is we have mill part probing, so we can do what we want to do here is probe the part with a milling machine. We can also probe a turning part, so if you're on a turning machine or turn mill machine, you can probe, with NX. You can also go ahead and set your tools. You can set your milling tools, or you can go ahead and set your turning tools. And then you can just also go ahead and create a type of generic motion, to go ahead and create this, okay? And so once I go ahead and create the operation, I go ahead and select a tool. I've got a probe. And then the next thing I do is I select a sub-operation, okay? And so these are the things that you can go ahead and do. So I can tell it to go calibrate on a sphere. So this will work for a 3D probe. I can go ahead and probe like a surface point. So if I have like an airfoil that I want to go ahead and probe a surface point, you know, at some funky vector, I can go ahead and do that. I can also, you know, update, you know, with machine control variables. I can go ahead and do that. Okay? And so what I'm going to do is, just for the interest of time so we can get through all the stuff here, I went ahead and created a mill part probing operation here. Okay? And so what I'm going to do is I'm just going to go ahead and quickly show you what I have here. Okay? So what I have is I have my my sub operations here. Okay? So these are features that I've gone ahead and created. So I've got protected linear moves. I have the control being updated, and you know, points being probed. So let's go ahead and take a look to see what that looks like. So I'm going to single step through this operation. So I've got my probe, and it's a protected positioning move off the side. Then it goes ahead and probes. Then it comes off. It positions and positions, and it goes ahead and probes, and then comes off. And one thing that you'll see here is I've got these machine control events. Okay, and these machine control events, this is how I'm, you know, writing these macro variable, like the position of where this is on the control. So I'm just updating parameters on the control, you know, variables or whatever that say where the points are, what it touched, where it was. So I go ahead and single step, and that's it. That's all I have. So what I'm going to do is I want to quickly go ahead and modify my operation. So what I'm going to do is I'm going to go ahead and add something. And so I'm going to do a positioning move here, and then I'm just going to move to like a point, and I'll say, and it's a protected move. Okay, so I've got that. And now, let's see, that's the last one. Okay, so there. So now what I want to do is I want to go ahead and probe on this bore. So I'm going to add a new operation, and I'm going to probe this cylinder. I'm going to select this here, and I'll go ahead and say OK. Okay, so it goes ahead and probes this cylinder. So I have that cylinder. Then I need to make sure that this goes ahead and retracts out of here. So I'll go ahead and say OK. And one thing is, I accidentally closed it, is I'm going to do another protected positioning move. Okay, so I'm just going to have it go back to that point after it's probed the cylinder. And then once I've done that, I'm going to add one more operation, and I'm going to have it probe, you know, on this back wall here. So I'm going to, so I'm going to do probe point, and then I will go ahead and select my point. Okay, so now it goes ahead and probes there. And I'm going to do another linear move. Okay, and so you're able to specifically, you know, control, you know, where this goes. And so if at your shop you have somebody that's familiar with probing, if you use a probe at all, you should be able to, you and your operator should be able to get up and running with this, with the macros. The thing with our competitor software is it doesn't use, you know, the controller macros that your operators and machinists are familiar with. So, you know, that's one thing that NX has going for it. So that is kind of on machine probing. Okay, so that is inside the NX for NX CAM program, okay? So the next thing I want to go ahead and show you is our CMM stuff, okay? So this is like a little known secret. So this is something that you guys will be able to use in the future. You know, if you guys don't have a CMM and use a CMM in the future, this is, you know, this is really cool. Okay, so what is it? NX CMM is a separate application within NX for programming, coordinate measurement machine, so CMM. So that's what it stands for. So what are the benefits for NX CMM? So NX CMM has 5 benefits. We have advanced capability, programming automation, inspection-ready output. It's an integrated solution, and it's ease of use. It's very easy to use. So first, we're going to talk about advanced capability benefits. So what we can do in NX CMM, we can produce better quality programs faster, and we can take advantage of the latest CMM equipment and inspection process. So NX CMM supports high-speed contact scanning and multi-axis scanning. So you can not just program traditional CMMs, you can program scanning CMMs, and then you can also program scanning CMMs that are multi-axis. So the most complex machine. And you know, one of our examples, I'm not going to show you here today, but you know, we have one of Renishaw's hexapod CMMs that's being programmed with NX. So there's a post for that. So with this, we can quickly respond to design changes and provide valuable measurement feedback to designers. So in NX CMM, we can program directly to design and manufacturing requirements. So we input 3D geometry based on a range of data translators. So we can import Parasolid, we can import SolidWorks files, we can import CATIA files, we can import STEP files, you know, whatever, you can do it. Okay, so whatever your customer's working with, NX can probably handle it. Okay, you can also program in the context, you know, of the CMM machine. Okay, in NX CMM, you can rapidly program with a wide range of feature and tolerance types. Okay, so what I have here is I have our features, and so when you program in NX CMM, you have, and it's a separate application inside NX. So in NX, we have CAD, we have CAM, we have drafting, we have modeling, you know, we have CAE, and we also have CMM. So it's one interface, you know, one fluid interface that you can go ahead and use to program your CMM. So here, you first create features, and then from those features, so if you're familiar with CMM programming, you can create a torus, and I don't think it's here in this list, a cylinder, a plane, a cone, whatever, okay? And then you can also apply tolerances to that. So you can rapidly program, you know, with a wide range of these feature types. Okay, and another thing that I'll touch on a little later is automatically update the programs using associativity. And then we can also analyze our results in a CAD environment. Okay, so we go ahead and probe, and we get our feedback, and you can kind of go ahead and see here that you can visualize what's out, which is really cool because you can see what's actually happening on your part. So you can see this feedback can be given to the designers, and they can figure out where they need to add more material. You know, maybe it can't be manufactured the current way, or maybe the programmer needs to change, you know, his strategy. Okay, the next thing I'm going to talk about is the programming automation. So you can save up to 80% of programming time with the automation of feature creation. That's a like a torus or plane, a point, whatever. Tolerance specification, like your GD&T stuff, true position, profile, path creation, the actual scanning paths of the CMM or probing points of the CMM, and then also collision avoidance. So with NX, you can achieve faster, repeatable CMM programming requiring less expertise. Okay. Okay, so now you can inspect features defined automatically from CAD geometry and PMI data. Tolerances are specified automatically using our PMI information. So what PMI information is product manufacturing information, and the inspection paths are based upon this. So instead of having the quality guy go ahead and define how he's going to go ahead and program this, because that's like when the quality guy programs stuff, he has to think about it, right? And so we take some of that, power away maybe, or, the ability to, change stuff, depending on their interpretation to kind of have a more standardized process. So the inspection path can be created automatically based on the feature types and methods. So this just kind of makes it so you program more consistently if you have this PMI information, and it also speeds everything up. So, so our PMI information, what it'll show is dimensions and tolerances, datums and targets, feature control frames, and associative notes. So just to be straight up with you, this takes some design effort up front. So, so instead of having the quality guy, spend a lot of time on, interpreting what your print says and how he's going to inspect it, you're going to have to be diligent when you go ahead and dimension your print, using GD and T, okay? But when it's inspected, you get exactly, what the designer wanted to check. Okay, and so this is kind of, the steps, of going through using PMI in a production environment. Okay, NX has inspection-ready output, so it's going to be right the first time. You're going to avoid potential collisions and potentially damaging your expensive CMM. And you're going to eliminate time-consuming testing on the CMM, so you're not going to waste hours, proving out a program. NX CMM simulates the actual code being used, and so it's not an internal simulation. It's processing, DMIS 5.2 code as it's going through, so it should show what's happening in the real world. And it's flexible. Inspection programs are not tied to a specific CMM brand of CMM. Okay, so we have collision avoidance and collision detection. So this intelligence is built in. So if it knows it's going to, if you tell it to go ahead and check for collision avoidance, it's going to automatically prevent you from auto-wrecking your machine. So that's a good feature. Okay, so with our inspection-ready output here, so with our inspection-ready output, we run the program in the context of a physical machining environment, and we use machine kinematics like acceleration, deceleration, so it's simulating the real world, and we identify and visualize interferences. Okay, so it's using the real world stuff. And then this program is, is ready to run. So it uses the DMIS standard 5.2, and to configure the output for each of the machines, you use just Post Builder, NX Post Builder. So this is this technology was built on NX CAM. Okay, so it's also an integrated solution. So you go from your CAD model in NX to CMM programming in NX, and you can go ahead And once you have your CMM results analysis, you can feed it back to the designer, and you can go ahead and update. Okay, this shows kind of like dueling banjos here. So on the top, it shows stuff the manufacturer or the programmer for the CMM, the CAM programmer is worried about, and on the bottom, it's you know, what the CMM programmer is worried about. Okay, so you can kind of work in tandem. You're working on the same system, so quality and manufacturing can work on the same part at the same time, looking at the same thing. So if anything changes, it's going to automatically, dynamically update and notify the programmer. Okay, so it's one of the great things is the associativity, and that everybody's using, you know, the same system, looking at the same thing at the same time. So the CAD guys, the CAE guys are looking at the same stuff. Okay, so our integrated solution benefits are we collaborate, you know, with an extended team, you know, working on it. So you have your designers, you have your CMM programmers, you have your CAM programmers, everybody's on the same page, and you can provide results analysis back, you know, to the design environment. Okay, so the most important thing here with NXCAM or NXCMM is our ease of use. So it's easy to learn the application and to get up and running. It's going to minimize training expenses. You can rapidly deploy this. So if you already have, you know, a Siemens PLM solution, you can integrate this into it, and you can adapt the application, you know, to your existing business process, so it's customizable. Okay, so this just shows, you know, the workflow. So it's going from CMM Inspection programming to DEMAS code. Okay. Okay, and the last thing I'd like to talk about is it's got a common API architecture. Okay, so like any automation that you write into CAD or CAM, the same like API interface journaling stuff is in CMM. Okay, so what I'm going to go ahead and do with the remaining time is try and show you as much as I can here. And it looks like I might have gone a little long, so I apologize for that. So what I'm going to do real quick is I'll just go ahead and show one example, and if you guys want to go ahead and see, you know, other examples, I can go ahead and show you later. But what I'm going to do is I'm going to switch to, you know, a part here. Okay, so this is an impeller hub. Okay, it's a fairly complex part. And so the designer was kind enough to go ahead and enter, you know, PMI information, you know, the profile, true position, run out, all this stuff. So that's great. So now what I do, instead of going into manufacturing, I could go into manufacturing for modeling, I can go into the CMM inspection. So I see this icon, inspection. Okay, so I'll go ahead and it's not going to let me here. So what I want to do is I'll just go new. And so here you can go ahead and see the different types of machines that are out of the box, and there's actually more than this. This is just what I'm going to show I have available for my demo here. So I'll use this one. Okay. Now what I'm going to go ahead and do is, this is the CMM programming interface. And since I have that PMI information I was able to look at before, this is the greatest thing about NX CMM is it automatically programs it based on rules that you have set up. So I can go ahead and click on this link to PMI. I can have it create my paths, it go ahead and create my tool, and automatically select what I've got here. Okay? And so it did a bunch of stuff, and it went ahead and recognized all this stuff. Okay? So it sees that there's a datum I need to inspect. There's another datum that I need to inspect. Oh, I've got an ID bore. I've got to check the profile. I've got to check the diameter. I've got to check the OD for circular runout. Okay, so this is stuff that the designer is interested in, right? And when we check stuff, we want to make sure that it matches what the designer wants. Okay, so this is good, because if he complains about the CMM results, you say, well, maybe I shouldn't have designed it that way. Okay, so what you can see is that it's automatically created a whole bunch of features from pressing that one button. Okay, so I've got the face, so I've got a bunch of planes, I've got some diameters, and then I also have, you know, these inspection paths. So I can go ahead and generate, you know, all these paths, and I'm going to go ahead and accept it. Okay, and since we have short on time, basically if I just press this one button, we will probably run into some gouge. So what I'm going to do is we have this collision avoidance. So once I've created everything, I can do collision avoidance, and I'm going to specify a safe plane here, and it's associative to what I pick. So I just drag and move that plane. Okay, so it went ahead and positioned everything, and now let's go ahead and see you know, what we've ended up with. So I'll simulate the machine. And that first spot, it looked like it whacked the part, but you can see this is automatically programmed, this blisk. So can you imagine how long it would take you to program that? You know, it's just amazing. So if you have a designer that is interested in making it so you use GD&T, and so you inspect everything the same way every time, this is a really good solution for you. So that's about all I have for you guys. If you guys want to see a couple of other examples, I've got some other stuff that I can show you at some other time. So feel free to contact me. If you want to take a screenshot, this is my contact information. And Candis, are you still there?
Yeah, I'm here.
Okay, all right. So that's all I have.
Yeah, like Matt said, you can go ahead and email him, or you can go ahead and give us a call here at Swoosh at 314-549-8110. If Matt's not available, we can definitely set you up with someone who can, you know, walk you through some more demos. You can visit our website at www.swooshtech.com. We have a form on there to ask a question. If you have any specific questions in the future, go ahead and, you know, hit us up online, or just reply to any of the follow-up emails to this webinar. And I also wanted to make a note that we do all the training in this. So this is pretty, you know, high-level, complex stuff. So we do customized training where Matt is an instructor. He'd be one of the instructors. So we can set up a very specific type of training if you need it. If you have any questions, go ahead and fill them in on the questions panel. And we have had a couple come in. The first one being, if I have NX, can I use on-machine probing?
Yeah, so if you have NX, you can use on-machine probing. So like in the past, it was like a separate option. Okay, but now in NX9, it's kind of like a standard thing. So if you have any of the mock packages in NX9 or higher, you automatically have this functionality. And one of the things is it's very easy to add this functionality to your post processor. So this is something, you know, it takes maybe 1 or 2 minutes to go ahead and add, you know, to most posts. It won't take very long. So it's very simple. The post processors for these macros are out of the box, so that's cool. So you can contact me if you want to figure out how to add that stuff.
Okay, and one more question. What CMMs do you support?
Okay, so like the CMMs that we support, so we support standard DMIS 5.2 code, so that's a DMIS standard. So we support all the standard or the manufacturers. So we have Renishaw, we have Zeiss, we have Mitutoyo, we have Sheffield. You know, all those manufacturers. And I think when I went ahead and showed, you know, this is just like kind of demo stuff here. But we also have some other, we also have like out-of-the-box install with NX. We have a whole bunch of machines here, and this is for the CMM here. So we've got Brown and Sharp, several Brown and Sharps, and so this means that the model and everything are there with it, and the simulation. Like I guess Hermle makes one. I didn't know that. Sheffield, Wenzel, Zeiss. So a multitude of manufacturers. Okay, and so someone that's familiar with NX CAM, it wouldn't be that far of a hurdle to make them a CMM programmer. So if you want to kind of combine roles, or if somebody wants to switch into like another field at your company, using NX CMM would be a great thing, and then it would treat it, a CMM operator might be able to become a programmer or designer. So it's great all around. So I hope I answered that question right.
All right, thank you. We have had a couple other questions coming along, but we are going to go ahead and email them through, or answer through email or phone, because we are running out of time. We're over 8 months over. So I want to thank you all for joining us today. We've had some good feedback already, and we have a third webinar coming up. I'll email everybody and let them know about that. You can go ahead and sign up for it. But thank you, Matt, for joining us, and thanks everybody for tuning in. Bye.